All right, we have a scenario here. We have a tank of water. When we start, the tank has 30 gallons of water in it. I have water going into the tank at 8 gallons a minute, and I have water leaking out of the tank at square root of t plus 1 gallons per minute. So question number 13, how many gallons of water leak out of the tank between time 0 and time 3? Well, I'm going to find out the rate at which water leaks out, and I'm going to integrate that rate from time 0 to 3. Which I can evaluate with an integral. That's going to be 2/3 t plus 1 to the 3/2 from 0 to 3, which ends up being 2/3 times 8 minus 2/3. So 2/3 4 to the 3/2 minus 2/3 1 to the 3/2. Feel free to leave your answer like that on the AP test. Here you might decide that you want to actually figure out the answer. It turns out to be 14/3. How many gallons of water are in the tank at time t equals 3? We have to make sure we're remembering the 3 kinds of water that matter. There's how much water we started with, there's how much water leaks out, and there's how much water comes in. So you could notice that we're going to start with 30 gallons of water. Over 3 minutes, water's coming in at 8 gallons per minute for 3 minutes, so that's going to be 24 gallons that come in. And we already figured out how much leaks out. That was our answer from number 13. So this is a great answer, or you could simplify it. Please don't spend time on the AP test trying to get a common denominator and add up those fractions. This is a fine answer. All right, so can you take this idea, now that you did it for one time t equals 3, could you write me an expression for how much water is in the tank at any time? Well, I'm still going to need to think about those 3 kinds of water. They asked me to call this function a of t. So a of t comes from 3 places. The 30 gallons of water that we started with, plus, here I like to integrate. This 24 came from us multiplying 8 gallons per minute times 3 minutes. You might also like to just think of, you have 2 things contributing to the rate at which the amount of water changes. There's how much is coming in, the rate is 8 in, minus the rate out is square root of t plus 1. And this is a most important problem from chapter 5 kind of question. Whoops, there I went, accidentally putting the same variable in my integral as I'm going to need for my upper limit. My upper limit's going to have to be t here. My lower limit is the time I start, which is time 0. This is going to be 8 minus square root of, pick any letter you want besides a or t, p plus 1 dp. Final answer. So this next one, if I was going to ask you what time the amount of water in the tank is the greatest, how would you just proceed? So you need to notice that this is an optimization problem. We're going to need candidate times. The candidate times are time 0 and, what was the maximum time in this problem? 0 to 120 minutes. So 120 would have to be on your list of candidate times. The other candidates you're going to need are times when the rate at which the water is coming in is equal to the rate at which the water is coming out. Why? Because you need the derivative of a to equal 0. Because that's when a has a critical point. And this is supposed to be how much water is in the tank. So we need critical points for a. And remember where a prime comes from. It comes from taking the derivative of the a function you wrote, which started with this number 30, which when you take its derivative is going to disappear. And the rest of your function was essentially inside an integral. So when we take its derivative, we're going to take off that integral, and we're going to end up with 8 minus square root of t plus 1. We're going to want that to equal 0. So I'm going to use algebra to solve this equation. 8 equals square root of t plus 1. I'm going to square both sides and get 64 equals t plus 1 to find out that t, my critical point, is when t equals 63. So that's going to be the other time I consider. And then I'm going to use these 3 values in my integral to find out how much water is in there at those times. Well, this one I already know. And I'm going to pick the time that makes the A value the biggest. All right, my apologies for question 19, because in this PDF that I have here, I can see that all the integral symbols are missing. But don't let this throw you off. This is you needing to find the area in between 2 curves. You're going to integrate. Well, double check. Could you draw in vertically oriented rectangles? Does the top always touch the top curve, which in this case is F? And the bottom always touch the bottom curve, which in this case is G? Seems to me that that is the case, which means we're going to be able to write an integral with respect to X. We're going to integrate from left to right, top minus bottom. Well, what's the leftmost X in this picture? There's a very clear boundary at the edge of my shading. The left edge is at X equals -1. The right edge of the shading, the furthest right point here, is at A comma B. I need the X coordinate, which is A. So I'm going to integrate from -1 to A, top curve, f of X, minus bottom curve, g of X, with respect to X. That is, even without the integral symbols, I can tell these are all wrong. So that must be a subtraction sign with an integral here. Your answer is D. Here I want the area of this region R. I'm going to have to find out if I can draw in vertically oriented rectangles. Does the top of my rectangle always touch the same curve? Yeah, it always touches this horizontal line, which I've been told is y equals 4. And do the bottoms always touch this curve? They do. I've been told that's this quartic function. So I'm going to find the area by integrating with respect to X. Top function minus bottom function. The top function is 4 minus the bottom function. You could write it out, x to the 4th minus 2x cubed plus 4. Make sure you have parentheses around that second function because the subtraction needs to get distributed. The only thing I'm missing now is my x limits. I know they have to be x limits because I wrote my integral with respect to x. So do whatever you have to do. This is, you could set the 2 equations equal to each other. So x to the 4th minus 2x cubed plus 4 equals 4. I'm going to subtract 4 from each side. So x to the 4th minus 2x cubed equals 0. I'm going to factor out x cubed times x minus 2 equals 0. That tells me x equals either 0 or 2, which matches up with my picture. So I'm going to integrate from 0 to 2. Here you would, not always, but I'm going to guess that they might ask you to actually integrate here. So I would simplify inside this integral and then use the reverse power rule to find an antiderivative. So I'll move my picture just a little bit so I can leave this up here. Now I want to revolve that region over the line y equals 4. So remember your process. You're going to shade in the thing that's going to get revolved. You're going to color this axis red. We're going to reflect this up above that axis, which is easier said than done, but it doesn't have to be great. And now I'm going to imagine I'm taking a slice. Notice that region R was totally flush against that red axis. There's no spaces here when I revolve this region, which makes this work a little bit easier. So I'm going to start my pen at the axis of revolution. I'm going to draw toward the curve whose equation I know. And try to draw in a blue radius. So I think that radius, it's a vertical line segment, so I need to subtract top y minus bottom y. The top y was 4 The bottom y was x to the fourth minus 2x cubed plus 4. If you decide you want to simplify that, that's fine. But remember what we're going to do. We're going to integrate. If I took my slices vertically, their thickness is a very small change in x. So I'm going to integrate with respect to x. I need area times thickness. Well, in this case, every slice has a face that's a circle. So it's going to be pi r squared. This is just me thinking through this. You don't have to write that. You probably wouldn't get any points for writing that. You might get a point. If you put limits on it, you would almost certainly get a point. But now we can write it. So this is going to be pi times the integral. I need x limits. I figured them out in the last problem. That's 0 to 2. Should be r squared dx, where r is 4 minus the quantity x to the fourth minus 2x cubed plus 4. Final answer.